Hello students, I am going to explain about why work energy theorem is introduced in physics. Why work energy theorem is introduced in physics. See that. To understand this, consider the forces acting on the raindrop. Raindrop falls almost at the same speed or some little bit variable speed, and two forces we can identify acting on the raindrop. One is downward gravitation force, another one is upward air force or air frictional force. Because of these two forces, the raindrop will fall almost with constant velocity. See, among the two forces, Fg and Fa are acting on the raindrop. Fg is constant actually. We confirm that Fg means gravitational force, which is constant. That formula is also known m into g. G is constant. G is called acceleration due to gravity. It is 10 meter per second square. Don't think that constant force implies constant velocity. Don't think that constant force implies constant velocity, but implies constant acceleration. Constant force means constant acceleration. Constant acceleration means uniform increase in velocity for every second. So under the action of constant force, you will find velocity to be increasing uniformly for every second. That is what you have to understand. Don't think that constant force is equal to constant velocity. The best example of constant force is gravitational force. F is equal to mg. This force is constant because m is constant and g is also constant, is equal to 9.8 meter per second square, which we approximate it to be 10 meter per second square. Up to 200 kilometers above the earth's surface, the g is constant, is equal to 10 meter per second square. By the constant acceleration of 10 meter per second square, the object falls with increase of speed of 10 meter per second for every second. See this figure. Here earth is shown. Above the earth there is a constant gravitation field, and g is also called gravitation field or acceleration due to gravity, and its value is 10 meter per second square. See, at different heights, at 30 meters, at 20 meters, at 10 meters, what is happening is force is force is equal to mg is equal to 10 newtons. See, at 30 meters acceleration is 10 meter per second square, force is 10 newtons. At 20 meters, the gravitation field is 10 meter per second square and force is 10 newtons. At 10 meters, the gravitation force is 10 newtons, g is equal to 10 meter per second square. But the velocity, you see that actually at every point you will find the gravitational force is to be 10 newtons, provided if the mass is 1 kg and g is equal to 10 meter per second square. But velocities are different. See that under the action of constant force, the velocity is increasing like this. At the beginning instant it is 0 meter per second. After 1 second it is 10 meter per second. After another second it is becoming 20 meter per second. The variable force is also expressed as F is equal to ma, but a is variable acceleration. Actually, whether the force is constant or not, whether the constant force is also expressed as m into a, or variable force is also expressed as m into a. Remember that gravitational force m into g is very similar to F is equal to ma. Okay, only a is replaced by g. Variable acceleration means velocity increases by different amounts in different intervals. That is what variable acceleration. Constant acceleration means velocity increases uniformly for every second, but variable acceleration means velocity increases by different amounts for every second. So if you express acceleration as a is equal to m into t square sine of xt minus exponential of 2xt, like that, a complex mathematical expression, then also we can use force as F is equal to m into a into mt square sine xt exponential of minus of exponential of x into 2t. But remember that many times we are not able to express the acceleration mathematically, and so every time we may not have mathematical expression for force F. See, the force is very complex in nature, so it is very difficult to express every force as mathematical. Not only force, many things in the nature are not possible to express with exact mathematical expressions. Only few things only can be expressed mathematically, and those few things we are using in our mathematics. But actually in nature there are many things which cannot be expressed mathematically. Similarly, the variable force can also not be expressed mathematically. Then what is the purpose of mechanics? The purpose of mechanics is to find velocity, displacement, acceleration, etc. of the moving object at a given instance. At different instance, you have to find velocity, displacement, acceleration of the particle, that is moving particle. That is what the purpose of mechanics. See, the above purpose, the purpose of mechanics will be fulfilled for constant force or constant acceleration. For constant force or constant acceleration, constant force means constant acceleration. Whenever there is a constant acceleration, you will have simple formulas for displacement, velocity and distance covered. The formulas are v equal u plus at, s equal ut plus half at square, v square minus u square equal to as. All these formulas are valid only when acceleration is constant. But purpose of mechanics will not be fulfilled when there is a variable force, because many variable forces cannot be expressed mathematically. See, these formulas are not going to be valid when there is a variable force. But purpose of mechanics will not be fulfilled when there is a variable force, because many variable forces cannot be expressed mathematically. I have shown one example of variable force. A force of bat on ball. See, in cricket we see that a bowler bowls a ball towards a batsman, and batsman will hit the ball with the bat, and the ball lands on the ball for a very brief interval. During that brief interval, the force on the ball can be plotted as shown in figure. This is a rough curve of force of bat on ball versus time, and this time interval is very small, about 100 milliseconds or 50 milliseconds like though. And this variation is not very smooth. It is some awkward curve, and this awkward curve, there is no mathematical expression for this curve. There is no mathematical expression for this curve. Only a rough mathematical expression can be formed, but there is no exact mathematical expression. So there are no simple or complex expressions to find velocity, displacement, acceleration of the object at any instant for the variable force. Therefore, when there is no mathematical expression for A, there is no mathematical expression for displacement, velocity, distance covered, etc. for the moving particle. This is the main problem of mechanics. But mechanics purpose is somehow you have to find velocity, displacement, distance covered by the moving particle. Here, at this difficult situation, scientists came up with idea of work energy theorem. The work energy theorem. The work energy theorem is to find velocity, displacement, acceleration under the action of variable force or constant force. Even under the constant force also, work energy theorem is useful. Even under the action of variable force also, work energy theorem is useful. Using work energy theorem, we can find velocity, displacement of a particle under the action of variable force. For this, I am going to give one example problem where we find velocity of the particle at a point under the action of variable force. Okay, I continue in the next video. Thank you.